The top our news here at 6 o'clock, an age-old dream becoming a reality. A local inventor has discovered a way, hear this, to use water to run your car.
It's a major breakthrough that will no doubt make motorists happy. And as Ralph Robinson explains, the Pentagon is also showing lots of interest in this project.
Water has always been considered a precious commodity, but Stan Meyer's invention may make it even more valuable. He has developed what's called a water fuel cell. It has taken the place of his old gas tank. The water fuel cell breaks down water molecules into oxygen and hydrogen. The hydrogen is used to run his dune buggy.
I don't care if you use rainwater, well water, city water, ocean water. If you don't have any fresh water, go ahead and use snow. If you don't have any snow available to you, then use salt water because there's no adverse effect to the fuel cell.
Meyer started working on this project 4 years ago. He's not a scientist. He isn't even a chemist. In fact, he never graduated from college. Myers was determined, he says, to design something to protect this country from oil embargoes.
And we have calculated that if we take the dune buggy from Los Angeles to New York, we would roughly use 22 gallons of water.
The Pentagon flew a lieutenant colonel in last week to look at Meyer's invention. There is talk of possibly using it in the Star Wars defense program and to run Army tanks. Myers is currently perfecting a water fuel cell for cars. It will cost about $1,500. He says it won't need any maintenance, and you won't have to replace it. It'll be at least 2 years before the fuel system goes into mass production. The day it happens will be one the fuel industry hates, but it'll put a smile on the face of those who've had to say at one time or another, fill her up. I'm Ralph Robinson.
As you can see, many patents have already been received, and many more are forthcoming. To date, over 42 patents have been applied for.
All right, that was a brief introduction into the Stan Meyer's water-powered buggy, and what we're looking at today is my attempt to replicate or get as close to Stan's gas processor, which was a critical part of Stan's water fuel cell, running the buggy on water, that a lot of people have overlooked, and the research is actually quite difficult to find on this thing. Not a lot of people have tried to build it. Some people on YouTube will notice Russ Grease did a build years ago of the gas gun, which it has similarities to the gas processor, but it isn't the gas processor. It's a different device. One of the difficult things in understanding what Stan Meyer did is so much of his work was so complicated and spread out over such a long time and fragmented that it's difficult to figure out what went where and things like that. So this gas processor that I'm building or replicating is, he calls it the Air Energizer, and it goes on his dune buggy that he built. Let me get over to some of the pictures here for you guys. So this is my gas processor replica, and when I say replica, it's a loose replica. It's not designed to look like Stan Meyer's, but it's designed to achieve the same results, to do the same things Stan did. So you've got a series of LEDs here. They're pulsed at a 50% duty cycle, somewhere between 0 and 100 hertz, I believe. I don't know the actual figure. This is another one of the mysteries in the gas processor. And the whole, trying to replicate Stan's work, it gets quite difficult to understand, where things were and what they were doing. Another shot of the gas processor being assembled. It's got an internal lens, and then that takes the LED light in and the photon energy in to the slots that are cut into these stainless steel tubes. So the photon energy comes in through this tube and interacts with air that's passing between the outer tube and the inner tube. These tubes are energized with up to 2 kilovolts, and the idea is that this is where it gets a little bit murky, but basically you're knocking an electron off the oxygen molecule and with the electricity, the high voltage electricity, and then you stabilizing the molecule by hitting it an inner orbiting electron with photon energy, enough energy to knock that electron up into the orbiting space that was left by the electron that you knocked off. This is Stanley Meyer's gas processor that was actually on his dune buggy. You can see his LEDs here. There's 3 of them at 120, 3 arrays at 120 degrees, 7 LEDs, or 7, I believe. There's a lot of detail about this stuff. It's probably easier if you join our Discord channel that Chris has set up. There'll be information about that a little bit later. But yeah, so this is the gas processor sitting on top of the car. Another shot with the cover on it. And this was absolutely used in when Stan was running this buggy, and in the footage you saw, this was on the vehicle. It was being used. It's got 2 outputs. There's various different configurations that he used it in. In one configuration, he sent the gas out to the manifold injection of the vehicle while he was inserting water fuel with the injectors. But I also believe that it was used when he had the carburetor throttle body, modified carburetor throttle body on top, did away with the carburetor, and this air was going into the engine. There is a couple of reasons for the gas processor. The first reason is the oxygen. This is a very long story. The oxygen in ambient air gets brought in to the engine through this gas processor, and it goes into the combustion chamber. Now, because the oxygen is missing an electron, when you go into the combustion phase with the hydrogen can't reform into a water molecule because that oxygen is missing an electron, and so the hydrogen molecule decays and becomes, I believe, a form of helium. And we'll hear Stan talk about that. Actually, I might just pause here, and I'll run that video for you.
And do it very safely. So the Lord was dealing with me, and in the process, the answer was very simple, that as you ignite the hydrogen and oxygen gases, if you will now prevent the hydrogen and oxygen atom to come together to form the water molecule, it cannot stabilize, right? If the water molecule cannot form during thermal gas ignition, then what will happen? Well, thermal explosive energy has to keep continuing to occur until 1 or 2 states occur, either that a new atom structure is formed or an implosion effect occurs and mass is converted into pure energy. The equivalent energy yield from 1 gallon of water is more than 2.5 million barrels of oil per gallon of water when you're talking about tapping into the atomic yield of water safely. So as a result of this, we are now starting to destabilize the combustible gas atoms. We're starting to pluck off their electrons in the process to decrease mass. We're adding electrical or laser energy to the process to bring it to a high energy state. Now we got combustible gas atoms coming off the water that is not in normal state, right? They are now in subcritical state. Go ahead. To do this, we now had to develop the electron extraction circuit, to pluck in the electrons, and you're now using the water as a source of the electrons as well as the gas.
All right, so Stan goes on to when he says, and we're now doing, it means he's moved on to an advanced level of development of that device. Stan had a specific process he worked through. First of all, he came up with his method of separating hydrogen and oxygen out of water efficiently, much more efficiently than electrolysis. Then he put it into the automotive use. Then he was approached, as you saw in the video in the intro, by the military for military application. Military application demanded that a lot more from his devices. So, not just able to produce the hydrogen required to run the military vehicles, but they wanted it to produce electricity as well. And that's why you see Stan go into, just before I cut out of that video, into the electron extraction circuit. Now that is a further on down the track. Yes, there is some electron extraction that takes place early on, but the gas processor doesn't actually have the electron extraction circuit not circuit, but extra filament built in. It doesn't have that. It's not. It wasn't designed for that, and it functioned without that. Give me 2 seconds. Where are we up to? So this is the gas gun that I mentioned, hydrogen gas gun from rust grease. This is not what I'm building. This is not what I'm trying to replicate. This device is substantially more advanced, and it does quite a few different things. I'm not going to go into it today. Quick picture of the buggy. Just over here, you can see the gas processor is fitted between the engine and the fuel tank. This is the injector setup just before it went to market. You've got the gas processor, the butterfly air gate that I spoke about just before, that restricts ambient air. So it's basically most of the ambient air is provided by the gas processor. You've got the injectors, the laser distributor, and some solenoids. Quick circuit diagram of electron extraction. So in this circuit, you can, if you're familiar with it, you can actually see the electron extraction circuit doesn't require the third electrode. And this is probably close to the circuit used in this gas processor. This is the actual water fuel cell, the cell that makes the hydrogen gas. And this is where we come into the second use that Stan was using the air ionizer, the gas processor for. There's a theory that we're working on that the ionized air gases were circulated back into the water tank, and it made water fuel. So it was dissolved into the gas. And there's parts of Stan's speeches and things where you'll hear him talk about this. So that ionized air goes into the orange fuel tank that you saw on the buggy, which is this orange tank here, and that is it believed to increase the yield of gas produced from the water. It's also believed that in the injector version that this ionized gas was in with the water that was sent to the injectors. It's just inside the 11 cell unit that powered. So this is the unit that powered the buggy. Each one of these was creating hydrogen. It had its own electronic circuit that controlled each one of them. That's called the VIC. We refer to it as the VIC-5, and we'll get into that a little bit later. That's just an internal breakdown of what was in that picture you just saw before. That's the outer electrode and the inner electrode. And this is stanslegacy.com. I have to give a big shout out to Chris and all the guys at working behind the scenes at stanslegacy.com. They are doing amazing things and have been an incredible help to my research and development. This is a quick, I'll just run you through a quick breakdown of some of the stuff I've found on stanslegacy.com. So all the patents are here, but more importantly, some of the critical the water fuel cell memo documents that were only sent out to sort of dealers. This information wasn't generally publicly available, and the guys have put this together for us, and it's made a massive help into figuring out how this stuff works. So Stan was very elusive about a lot of stuff. He didn't give a lot of stuff away initially until he got his patents locked in, and his patents are a whole different story. You know, there's Stan explains that he patented his technology in a way that no one could slightly alter it and say, oh, it's different, but and get another patent. So it makes it very difficult to understand what embodiment was being used, what device was being used, where and how, and understanding his patents and his circuit diagrams is quite difficult. You have to listen to his videos and pick up keys from him, and you have to work backwards because the really really important stuff he didn't release at first. It was stuff he didn't talk about until he had dealerships up and running, and he was just about to get this stuff to market. So the gas processor that you saw on the dune buggy, which is what most people see first, is the dune buggy running on water. This air ionizer gas processor is we believe quite critical to the whole functioning of the water fuel cell. But here it is listed under a differential air gate inlet control. If you look through the memo, it's under the water fuel cell injector, auto injector system, aviator, rocket engine applications. I mean, seriously, I wouldn't have thought to look here, but anyway. So in his documents, it's referred to as the differential air gas inlet control design, and it just goes over the so that's your gas processor. It talks about advanced concepts of state space tickling. So we're not actually ionizing the air, which is why I didn't call it an ionizer. What he does is something slightly different to that. But yet you're not having current flow through this device. It works differently to an air ionizer, I believe. But anyway, so your air would come in, your ambient air would come in through the gas processor. There's also an air filter and an ambient air input as well in this particular design. It would go into a mixing block and be metered, and then sent through into combustion. It also brought in exhaust gas, which was mostly H2O or steam. It goes into the actual schematics, the how to build the thing, which I found really important. So if you'll see here, he's got LEDs. They basically shine through the two electrodes, and the air comes in through here, through there, down and out through the inner tube, and out through gas port here. So these designs were incredibly helpful when I was building my replica. I couldn't have done it without this stuff. My replica isn't exact because I don't have access to this stuff. I don't have a 3D printer. I don't. The materials Stan built this in are harder to find these days, and it's quite expensive. So I built it basically with what I have. But a massive thanks to Chris for getting this site up. All the patents are on here and things like that. As your circuit board layout for your LEDs, and yeah, it's an amazing job. Also runs a Discord group where there's people in there doing research and development, and it's absolutely brilliant. So stanslegacy.com if you're interested in getting involved in us. It's an international community, and we're just trying to figure out how everything worked. It's there's guys in there you can sort of ask and bounce ideas around, because obviously no one's figured it out yet. Otherwise, there'd be June buggies running around everywhere. The other issue we have is, we're doing this on our own spare money, or on our own time, and it's open source. Everything we discover, we're quite happy to share. There's so much of this tech that gets put out, and it goes into, people get funding to do the research, and once you get funding, you're locked into a contract. You've got non-disclosure agreements, and this stuff goes and gets developed. By the time it gets to the shelf, it gets to market. People are out there with their hand out for funding for huge amounts of money to mass produce this stuff, and some guy just buys the idea, probably for an oil company, shelves it, and it's never seen again, and the knowledge doesn't get out there of how to do this stuff. All right, so this is where I started the build. Basically, as I had a little bit of spare money come in, I'd order bits and pieces, and I'd start figuring out how I was going to build it. And the first thing, the easiest thing to figure out how to build for me was the LEDs. The LED control was fairly simple. I'm no expert at electronics by a long shot, and I've learned so much just building the stuff to do this. So yeah, three arrays, 3 LED arrays, 7 LEDs. The red light should be 660 nanometers to interact with the second layer of electrons in the oxygen molecule, and the pulse rate is, we don't know. Yeah, it's somewhere between 1 and 100 hertz, I believe. It's just the back of the LED board. I went with Stan's design and used resistors on each LED. I figured he did that for a reason rather than easy ways of doing that. That's just the inner tube of my gas processor as I was fabricating it. It had to I think the original one was probably solid. Stan doesn't show the original inner tube in his designs anywhere that I've been able to find. Basically, I machined this up, cut it out with a hacksaw, a grinder and a hand file, smoothed off all the edges because you've got high voltage. So any sharp edges, the high voltage will build up and peak there and arc over. So it was quite a painful, slow process to build these things. That's just a quartz lens off like an eBay ozone generator. Stan, I believe, used a quartz lens of a much thicker lens, and or it might even be acrylic. I think Max used acrylic, but I think Stan used quartz. Um, that's just the the outer tube, the outer electrode. As I was hacking it up and polishing it, this is during preparing for assembly. Big, massive thank you to Wayne for letting me use his lathe and workshop to turn all this stuff up. I couldn't have done it without you. And that's just more assembly. All right, so building the gas processor is one thing, but the trickiest thing that many of us have sort of had over the years is understanding how Stan Meyer's voltage intensifier circuit works. Basically, it restricts current, so it uses high voltage potential to do all the work, and that high voltage potential is pulsed at a given frequency, somewhere around 5 kilohertz, I believe, but it depends. So I had to build the closest thing I could to, based on materials I could find at a reasonably cheap cost, a similar type coil designed to Stan Meyer's voltage intensifier that he used with his gas processor. Give me a second. I might pause here and grab another image and just show you the original one. All right, so this is a picture of an original Stan Meyer VIC 5 voltage intensifier circuit coil design. You've got your primary coil here in yellow, which Don Gable, a guy who got his hands on this stuff shortly after it was recovered from his estate by his wife after the courts released it, did some measurings and some findings and wrote them all down. Basically, he measured the primary as 500 turns. This is the secondary. That is, it's just under 3,000. It's 2,900 something turns, I believe. And the chokes are almost the same as the secondary. So this is the negative choke. That's the positive side choke. And the center green is was used to tune the circuit through the phase lock loop. It ended up being 5 volts. That's his switching transistor, I believe. I could be wrong about that. There's also, or it could be the diode in here somewhere, but there is a diode between the secondary and the positive choke. Or it could be the negative. Don't quote me on that. I haven't got the diagram in front of me. So anyway, that's Stan Meyer's voltage intensifier circuit, and that was used to drive not only each individual cell in the water fuel cell that I showed you earlier, but it also drove the gas processor. So here is my attempt at replicating it. You can see I've got a primary here, that's 500 turns. The issue I had is I could only get 1,500 turns onto these bobbins that I made by hand. That's all you're going to fit on this particular transformer coil, which was one of the few transformer coils I could find that looked like it would reasonably do the job. And this whole transformer business is one of the most difficult, complicated things I've ever seen. It's worse than nuclear physics. It is incredibly difficult. There's so many variables and so many factors, and Stan's information on it is quite difficult and unclear. So basically, I was going to wind a third one at 1,500 turns. So you've got 500 turns at the top on the right, and the two bottom are 1,500 turns. There was going to be a third one but the bobbin failed at 1,499 turns. Stink. Anyway, this didn't actually produce anything useful. This configuration. I ended up reducing the primary to about 20 turns of some slightly thicker wire, and it basically became a flyback transformer and produced somewhere in the range of about 5 kilovolts. Because it was, I didn't have the chokes. Well, I had a positive choke, but I didn't have my negative choke because the winding failed. I couldn't experiment at this stage as if I was replicating stand stuff, but I did learn a hell of a lot. In the process of making these coils was just a bit of PVC drain water pipe plastic that I expanded over a socket with a heat gun, so I could slide them over, cut them to length, and then I cut and glued on the end caps for the bobbin. And obviously I failed at doing one of those properly. But this did produce some incredible voltage through experimenting. This arc here is probably the best part of 4, 5, 6 millimeters, and it's roughly about 3,000 volts to jump an air gap. So yeah, that's got to be 5 kilovolts jumping right there. That caused a side problem for me because it ended up, I didn't design my windings and bobbins and coils for 5 kilovolts. I was only aiming for 2. So when you start getting up that high, the voltage tends to arc across everything. It's if you haven't got enough insulation, which I hadn't planned for that sort of voltage, it arcs across all kinds of things. So it was arcing between one of those big bobbins you can see there, straight over to the core, and the core actually became very high voltage, which was interesting to find. If you take a note of Stan's coils, you'll see the Delrin insulation around the coil, around the core. Now, I'm pretty sure that's because that core became hot. It was electrically high voltage, and so it had to be insulated. That's also why it's encapsulated in a metal case to reduce radiation or interference. All right, what else did I find while I was making this? I think that is about it. So this is where I'm at. There's a little bit more experimenting to do. I really need to wind that other bobbin and or make that other bobbin solid and wind it. And I'm kind of stuck at the moment because I have never created anything over 600-700 volts. When you get over 1,000 volts, your multimeters they don't handle it. They arc across the terminals and you start killing them very quickly. And I had an old scope, like a kit scope that you put together. It was off eBay or something like that. It was cheap, but that got me through till this point. But unfortunately, the high voltage killed that as well. So I'm a little bit stuck for measuring devices at the moment. Going to take a little bit of time to have a think about how I can measure the effectiveness of the gas processor and how I can replicate Stan's Vic coil a little bit better. I really need to wind that other 1,500 turn bobbin of wire and give that a crack. So that wraps it up for this update of the gas processor. I hope I've clarified some stuff. I've sort of rushed through it. It's quite a bit of information. There's a lot to go through, and I've only just skimmed the surface of it. But like I mentioned before, you can join the Discord server if you go to stanslegacy.com and get in touch with them. And if you want to get involved, or you can get on our Telegram channel and you can contact me that way. All right, guys, that is the update. If you've got an old scope, oscilloscope that you want to donate, that would be helpful. Otherwise, I've got to save up for one. And I've got to get some multimeters and some other bits and pieces, and I'll keep pushing ahead. All right, take it easy.